In this module, we are going to focus on Bezoit coefficients. The reason we are studying this is they will play a critical role in the public key cryptography scheme that we are trying to study. We are trying to build different parts of it in these modules, and then we'll combine it in a subsequent module later. So Bezoit coefficients are based on computation of GCD that we studied earlier using Euclid's method. So Euclid's method is the one where we don't factorize the number. So what we have here is a theorem that says that if I have two numbers n and m, I can express the GCD of those two numbers using this expression s times n plus t times m. Note that all of these are integers, no fractions, and that's going to be an important part in our analysis. So the way we are going to do that is we are going to use the algorithm for GCD, and as part of the algorithm of GCD we can compute the value of s and t. S and T are what are known as Bezoit coefficients. Note that they are not unique, but that's okay. If we have one, we can find others fairly easily. So let's look at an example. Here we have two numbers 630 and 196. What we have here is a way to compute the GCD of these two numbers. So what we're going to do is we're first going to express the bigger number in terms of the smaller number. So we are going to divide 630. We are going to divide by 196. And what we are going to find here is that the quotient is 3, the remainder is 42. Then we are going to proceed to take these numbers 196 and 42, proceed further. So we are going to express 192 as something times 42 plus the remainder. So in this case, the quotient happens to be 4, the remainder happens to be 28. We continue further. We continue with the numbers 42 and 28. We express 42 in terms of 28 times something plus the remainder, in this case 14, and at the end we get remainder to be 0. When the remainder is 0, that's when we stop. Now what we did here is we computed the GCD. We can use the same analysis to find the value of s and t. So the way we're going to do that is we're not just going to find the GCD in terms of the original numbers, but rather what we're going to do is we're going to look at each of these numbers, each of these remainders that we have, and express them in terms of s and t. So the remainders that we have are 42, 28, and 14. Now, the way we are going to do that is as follows. I'm going to take this expression and rewrite it as 42 is equal to 630 times 1 minus 196 times 3. So that's the expression that I have over here. Now, we had letter n representing 630, m representing 196, so I can write R1 to be n minus 3m. We proceed further. we write R2, in this case it is 28. I'm going to write it as 196 times 4 times 42, and I got that directly out of this expression. Now 42 is not one of my original numbers, so I'm going to replace it by n minus 3m. This is what we had over here. 196 is one of our original numbers, which we were calling m. So in that case, we're going to have m minus 4 times n minus 3m. Then do a little bit of algebra to get to this expression. So essentially, in this case, what we have is s is equal to minus 4, t is equal to 13. Note that we have not reached the GCD yet, so we need to keep doing this further. We go ahead one step, we write 14. 14 in this case is 28 minus 14. So in that case it is R1 minus R2. Now R1 and R2 are not our original numbers, but I know that R1 is equal to this expression. R2 is equal to this expression. So we are going to substitute it, do a little bit of more algebra, and we will get this. Note that when we got this, at this point what we have is s is going to be equal to 5 and t is going to be minus 16. Here is another way to look at the computation of s and t. Here I'm going to represent all the values in a table, and I have provided you a spreadsheet to do this analysis yourself. So if you change the value of n and m, you will get different analysis of this. So what we have here is we are computing the remainder at each stage, and we are finding the value of s and t. What I want you to observe is the way we got these values is exactly like what we showed in the previous slide. We said 42 is expressed as 630 times 1, which went here, plus 196 times minus 3, which went over here. You can verify that this adds up to 42, which is what is expected. We continue this for every iteration, and when we get to this entry, we have reached the GCD, and these values will be the values that we need for Bezoit coefficients for 630 and 196. Here is another example. So here we have the computation for finding GCD between two numbers, 252 and 198. Now this approach is sort of backward in the sense that we're going to start with the GCD and we're going to express it in terms of the numbers that we have in it. So for example, I'm going to use the first equation here, this equation over here, to write 18 as 54 minus 36. Now 54 is not our original number, 36 is not our original number, so we want to replace them to get to the original number somehow. So in this case, I'm going to replace 36 by terms. So this is my 36. I'm going to express it in terms of 198 minus 3 times 54. Wonderful. So now I got this expression 54 minus 1 times 198 minus 3 times 54. Note that what we did here is we got rid of 36. Let's continue further. We want to get rid of 54 as well. So 54, I can use this expression and replace it by 252 minus 198. Again 252 minus 198. Note that 252 and 198 are my numbers, original numbers, so I'm going to keep them as is. And I'm just going to group them in terms of multiples of 252 and multiples of 198, and that will give me 4 times 252, 1 coming from here, plus 3 coming from here, and minus 5 times 198. As mentioned earlier, Bezoit coefficients are not unique. So for example, once I have one set of Bezoit coefficients, here I have 4 times 252 minus 5 times 198. I can also find other terms such as 15 times 252 minus 198 times 19. Note that the way we can find these other Bezoit coefficients I have described in the spreadsheet that I have given you, because the thing that we really need is to find Bezoit coefficients when the GCD is 1. We will need to find multiple Bezoit coefficients in that scenario, and I have discussed that in the spreadsheet that I have given you. Once again, we have reached the check before you proceed slide. What I want you to be able to do here is choose any two numbers, 2-digit. Do the same analysis that we did to find the value of S and T. Verify if the value of S and T you got is correct. Note that you can verify fairly easily by just doing S times N plus T times M to see if you get the GCD. I would like you to do the review quiz at this time for this module.